Hello everyone and welcome back to Step by Step Coding and our top 100 C# interview questions deep dive series. Today we are diving into one of the very interesting and frequently asked question: what is the difference between value types and reference types? This is not just an interview question, guys. It is a core concept that explains how your C# applications manage memory and perform. Whether you are a complete beginner or looking to solidify your advanced understanding, we are going to start from the absolute basics and going all the way to the low level memory implications. Uh, this episode can be a little bit longer, but I request you that please bear with me. We are going to start with some basic fundamental concepts. We will try to understand what is the value type, reference type. We will go through some basic definitions. Um, we will try to understand the concepts, and then finally, I have probably 7, 8 different, the code set, which we will review, and we will open the Visual Studio Editor, and we will try to understand that what is value type, what is reference type, which variable goes at what place. So let's start. Uh, we will start with pretty fundamental definition. So in C sharp, every variable which we declare fall into one of these two categories. On the left, we have value types. As the name suggests, a value type directly contains its data. Think of it like a physical box holding a specific number, a character, or a true-false statement. When you declare a value type variable, its memory location is where the actual value is stored. When you assign one value type variable to another one, you get the complete copy of that data. So, I mean, in simple term, value type is something like, you have something like physical copy. Okay. On the right hand side, we have reference type. So these are fundamentally different. Reference type variable doesn't directly contain the data. Instead, it contains a reference, essentially a memory address. Now, in value type, in this diagram, if you take a look, we have a box, and within that box, there is a 42 number. So 42 is a data, right? So that box, yellow box, actually a representation of a memory block where the actual data is stored. However, if you take a look the reference side, we have two boxes. In the first box, you have a arrow which is pointing to another box. So that is why we call it as a reference type. In reference type, what happens that data is actually stored somewhere else, and we will talk about that where the data is stored. But reference type is that it is actually a pointer which is pointing to um, something else. I'm not sure, I mean, how many of you have already coded and worked on in C++ in past. If you have, so you might be already familiar with this concept, the pointer. So reference type is pretty similar, the same thing. And that is why in C sharp, right? I mean, by definition, we call it as value semantics, right? So what happens that in value type, when like I said earlier, when you copy one variable to another, you get a new copy. So it's like, think about it like if you are actually holding a physical book on your hand, and if let's say somebody else like that book, you actually prepared another copy and give it to him. So you have one copy and other person is having another copy. And let's say, I mean, the other person writes some notes on his copy, in other words his book, obviously it is not going to reflect on your book, because now you both are holding two different set of copy, right? A reference type, I mean, how I should give a explanation it, think about it, that same book, the scenario, that the book is stored in library, right? And the other two-person, you both are having, the library card actually, where you can use your card and you can go and you can take a look that same book. And then someone, another person is also having a library card, and he can also go and take a look the same book. Ultimately, you both are actually referring the same object, the same book, the same copy. Now, at a basic level, we understand now that what is the value type, what is the reference type. uh, Now, in order to completely understand the value type and reference type, we need to understand the philosophy, that why the value type, why reference type, and what relationship it has got with the stack and heap, right? Until unless we don't understand what is a stack and heap, we will not able to understand what is the value type and what is the reference. So let's spend some time to understand uh, what exactly is the stack and what exactly is the heap. So a stack is like a neatly organized stack of plates. It's a contiguous block of memory. Contiguous means, the all the memory, the blocks uh, is in the series, right? And it is fast. It's used for the local variables and method call information. So when a method is called, a frame is pushed onto the stack containing its local variable, and the moment method completes, the frame is popped off and the memory is instantly, I mean, you get free, right? So so this is where the stack is where your actually value types reside. For example, I mean, in this case, if you see int a equal to 5, the variable a and its value 5 are actually on the stack. The heap, if it is kind of, the large disorganized warehouse. uh, it is a reason of memory used for, the dynamic memory allocation, and where objects can live for longer duration, and it is independent of method calls. So when you use the new keyword to create an instance of a class, for example, I mean, in this picture, if you see the person p equal to new person, the moment object is getting created, the data, the actual person data is actually gets stored on the heap itself. So, and string name equal to j, I mean, the same thing, that uh, the data would be stored on the heap. Now, theoretically, I mean, we did talked about it, right? But the $1 million question is that why, what the heck is, I mean, why Microsoft came up with this, the stack and heap, these two memory model, the approach for a, the .NET, for the .NET platform. So I would try to, explain this concept with a pretty simple, day-to-day life activity, which we do, which happens in our house, right? So stack is like, it's like kitchen countertop. Think about it, that you have got a small space. So stack is like a countertop, which is a small space, but it is very fast to access it. It's very fast to do your stuff, to do the temporary task, like chopping a vegetable, placing in, the ball. When you are done with something, you clear the space quickly, right? And you start doing another things. Once that is done, you clear it. So each time you are kind of, you are popping a stack frame, right? You are reclaiming the memory and you are going for another one. So it just like the, the kitchen countertop, stack also does the same thing. You use it, for your local variables, and once it is done, you free up the memory. What exactly is the heap? Heap is like, your kitchen pantry. where the objective is to store your big and the longer duration items until it is expired, right? I mean, if something got expired in your kitchen pantry, what do? You throw it out, right? So same thing, right? uh, but it is not as fast as the stack. Why? Because to go to the pantry, bring the stuff from there, obviously, from your kitchen place, right? You go, you walk there, you go inside your kitchen, the pantry, then you take a look, you do not know which stuff is there, right? So you locate it, you try to find it out, right? And then you use it. So there is a overhead involved. So that's exactly the same way stack and the heap works uh, when a .NET program runs. Now, in addition of that stack and heap, I wanted to point it out a few other things as well. Uh, Pretty soon, I mean, we are going to cover the code as well, and we will actually see which thing gets stored where, right? But apart from the stack and heap, these are the not only two things. And one thing actually I pointed it out, stack and heap, ultimately it is the same RAM. Okay, you got a machine, you have a RAM, right? The same RAM is divided between the stack and heap. And as per my understanding, I believe what happens that on the Windows platform, normally by default each thread normally stack, right? Stack gets 1 megabyte space. On Linux machine, I think by default it is 8 megabyte. You can change that. I mean, it is a by default variable. When you do it, let's say you create another thread, there you can specify that. I mean, you want to have this MB, but by default, normally on Windows platforms, it's 1 MB, and heap is obviously it is a dynamic allocation, right? So it can keep increasing. Uh, but let's say, I mean, this program .NET, the runtime engine is how it is going to allocate the memory. Obviously, the first portion is the operating system and uh, the system, the OS and .NET runtime, the whole thing occupies some space. Then you will have the code segment where the code which you write, like main and all that things, right? It goes under the code segment. Compile instructions, where the compiled code gets their data segment. And a static counter is the place where you have static variables. All those will go into a static counter. And obviously then you have got stack and then heap. In this example, I mean, a is local variable, so a goes into a stack. Name is a string, which is reference type. So the actual data, which is a jar, that will go inside the heap. But the pointer, right, the reference, that actually will go to the stack. The same thing goes for the person class, where the data, right, let's say if you have like the name and some other things, height and all that things, color, if you have all those the different data, so entire the data will be stored on the heap. But the reference would go on the uh, stack. Now uh, obviously, I mean, we wanted to focus on the stack and heap for this question, but I just wanted to point it out that these are the other memory portion uh, as well, where memory gets allocated when you run a C# program. Quickly, we will take a look, just the logical presentation. I know these numbers are pretty off, because the most of the time, right, except operating system, and .NET runtime and all other things, right, most of the space gets allocated for the heap as well, because this is where you actually store the large and complex objects, and for the long live objects, right? Stack normally is having pretty the small space, like I explained, that it is 1 MB by default for a thread. If you obviously create multiple threads explicitly, or you use like async and all that things, right, so internally it end up creating not only the default thread but other threads as well. And in that case, you can have the multiple a little bit more space. Now, having said that, now I think we have fundamentally established what is the stack and what is the heap. Now we will try to actually go through the code portion, and we will do some, the experiment, and we will try to see. We will go a little bit more deep dive. So let me go to my, the Visual Studio Code, and I will start with, let me see, I think I have some of the files I have hidden it. What I will do, let me enable all these. Okay, so let's take a look this one. We will start with example one.cs. Pretty simple code, right? I mean, one small, uh, the main function, and we have these, the two local variables created, num1 and num2. Uh, on line number 18, we are starting with the declaring and assigning num1. Obviously, the way the program is going to run, the first thing what actually it's going to do, that on line number 15 it will find out that it is a main method, so it's going to allocate, it's going to create one, the main uh, uh, main, the stack frame. Within that, it's going to allocate num1, and right away, since it is, getting stored on the stack, it's going to put, num1 equal to 5. Let me do one thing. I should have one actually the pick for the allocation, and we can take a look. Yeah, here we go. So let's take a look. So we have got stack, we have got memory, we have got stack, we have got heap. In this program there would be no heap allocation, so that is why heap is empty. So we are inside the stack, and within that stack we have mainframe. This we are talking about. Wait a minute, let me try to do one thing. Okay, so this mainframe we are talking about, this mainframe is this one. Uh, this main method, it is creating a main stack frame, and then all the local variables, right? All the local variable, primitive data types, everything was going to be stored here itself. Um, so num1, we got num1 variable. It is started with number 5. Then we have another num2, again the value type, so it will have their own space. This one is nothing but the hexadecimal code of the the storage location. The same thing here, since these two variables are going to be stored on the stack, so both will have their own location. To start with, num1 equal to 5, this will have the 5 initially. Then we have num2 equal to num1. What actually it means that this will have 5 as well. Now like I said, I mean, in the definition, that if you copy, right, a value type, if you assign it, you get a different copy, right? So that another value would be created. I mean, this is that copy, this is the second copy. So now both copies having 5 and 5, both copy is having, I mean, 18 19, you have 5 and 5. Now what we are doing here, num1 equal to 10. So what actually it means, that here we are changing the value from 5 to 10. Now obviously, if you see by this memory representation, these are the two separate boxes. We are changing num1 equal to 10, so this, I mean, this 5 would go away. We will have 10 here, but obviously these are the two different boxes. There would be no impact on this. If you run this program, obviously what is going to happen, I mean, you print it out, you will have you will have num1 and num2. Obviously you will see two different values, because these are the two different boxes. Okay, now let's quickly move to example 2. So let's see in example 2 what is going on here. So same thing, I mean, example 1 we actually covered the all the value types. In example 2 I have put in the 2, I'm bringing 2 the variables, which is a reference type, just to understand that how the data is going to be stored for this the small programs. And let me quickly open the memory allocation for this one. Now, see here what is happening. We have the main stack frame again on line number 14, which is int num1 equal to 5. We got this thing got created. Okay, this one got created on line number 14. Then 15 and 16 we are creating employee 1 and employee 2. Now these are the reference types, and like I said earlier, in reference types the data actually gets stored on the heap. So when I say data, what does it mean? So your employee class objects, right? Your employee class, the data which is having ID, right? So the moment, I mean, this line number 15 is going to be executed, what CLR is going to do, it is going to find out this new keyword, then it will go here, it will try to figure it out all the local variables and entire memory which is needed for this one object, right? So it's going to compute what are the different, the bytes it needed, and then it will allocate that space somewhere within the heap. Once again, I mean, as we know that heap is a disorganized, the area. It is not a contiguous memory. It is a big like warehouse, right? You can put stuff at any place. So it will find the space somewhere in this large block of the heap, which you see here. It find a space here. It put it ID, and then this is that location, this address 0x200. So it allocated, it put it that, it got the reference, and then it give the reference back to emp1. So emp1 will have that their own address, keep in mind. Okay, so emp1, the actual emp1 reference, right, it's going to be stored on the stack and it will have their own address as well. But what data would be stored in that? Because reference doesn't store directly the data, but it is stored the reference of the another data. So in terms of the data wise, it's going to store the reference which is the 0x200. That means what we are saying, that this is the address of this heap and that address would be stored here. So that is a fundamental difference between a stack type and the stack and reference. Okay, now same thing imply 2. You have another object, right? Another employee object, and then same thing. So it is, the basic. We are not doing any reassignment here in this program. It's a simple, the representation, just to understand that how, the values types and reference types differs and where the memory gets allocated. Now let's quickly move to the next question. Now here what actually we are doing that, let me get the memory representation as well. So we are creating a box one. We created one box one object. Again, it is a reference type. So data would be created on the heap. Then box two equal to box one. What actually it means that another variable we are declaring and assigning with the box one. So the key thing is here. So box two equal to box one. Now think about it. What is this box one? Just like in previous examples we reviewed it, box one is a reference and actual data is stored on the heap, right? But we are assigning box one into box two. So what exactly it is going to assign? It is actually going to assign the memory address, that reference, not the actual data, right? So let's quickly take a look here. So if you see here, we have memory address 0x300 of the heap. Box 1 is having 0x300. It means in the data we have the memory address of the heap. Now we are assigning box 2 equal to box 1. So what actually it means that box 2 is going to have the 0x300. Obviously it will have their own address on the stack, but in terms of the data, now since we reassigned it, we reassign box 2, assign box 2 into box 1. So box 2 is going to have the address of this thing as well. So what actually it means that now you have got two objects, both are pointing to the heap. This is the fundamental difference between, the value type and reference type. Since this is a reference, actually we are copying the reference. In value type, you actually copy the actual data itself. Okay. Now, once box 1, box 2 both are pointing to heap, we have a simple assignment here where we are changing the value box 1 dot value equal to 10. So now box 1 dot value equal to 10, since both, I mean, it doesn't matter, right? I mean, whether you do box 1 dot value or whether you do box 2 dot value, ultimately the point here is that both are pointing to the same. So it doesn't matter through which reference type you change the value, it is going to be reflected at both the places. Because think about it, it's like, you're the library book, single book, which two people have got the library card. So if you bring your home and you make some, the changes, whenever other person is going to check that book, he's going to see the same changes. So that's exactly the same thing is happening here. Now quickly let's move to the next example. um, I have tried to put some variation here so we all can the cover most of the scenarios. Now in this case, what actually we are referring, we are actually passing by values. So far what actually we did that, we saw that when you declare the the data type where it gets stored, when you declare the reference type and assign the value where it gets stored, when you assign a value type variable into another one, how the data gets stored, and same thing we did for the reference type. Now in this example, what actually we are going to do that from one method you are actually passing a value type to the another method. And how does it works, how the data gets stored where? So you have got the mainframe, the stack. You have original equal to 10. Obviously, I mean, it is going to be stored within this, the stack frame itself. And then it is calling another function and it is passing, this original value. What actually it means? So original is a data type. So if it is, a value type. So since it is a value type, when you are passing, what actually it means that it will pass a copy. Okay, remember, so when you assign a value type, it creates another copy. So you are actually passing original into this one. So what will happen? One more interesting thing, right? I mean, this is the first time we saw so far that we have two functions, one function calling to another function. So one thing to note that when this function would be executed, obviously this is going to be executed first. It is a static void main. So this will have your the main stack frame, but since this is another function, so you are going to have another the stack frame. So you are going to have the two stack frame. Okay, so let's take a look. You have one stack frame for the main. Okay, so one stack frame is here, and then you also have another stack frame here. Okay, now both are going to store their own the local variables within their stack frame. Okay, so this has got original, and then this gets passed into this stack frame. Now when this gets passed again, I mean, this is what actually it is going to pass. It is going to pass the actual data itself because it is a value type, right? So it's not going to pass the address, it is going to pass the 10, right? So once this function would be called initially, this number variable will have 10. Okay, so that time both are going to have 10 and 10. Now on the line number 16 in here actually, so we are assigning number equal to 99. So what actually it means? It means that this thing which was initially 10, now its value changed to the 99. But keep that thing in mind that yes, I mean, this would be changing to 9. But what actually it is doing, it actually changing the value itself within on the stack itself. It is not going to reflect anything on the other stack, the frame, the variable. So this will have 99, this will have the 10. Okay, now let's move to the next example right away. Okay, so in previous example we saw the the calling a function and passing by the value type data. Now here in this example we are going to see the passing by the reference. Okay, so let me take a let me open this, the memory presentation as well, and we will go a little bit, the quick here. So score, my score equal to new score. Again, score data would be created here. This has got, the reference of that heap 0x400. Now from try change score, that is another, the method, it will have their own thing. The interesting thing is that what we are passing here, we are passing my score. And what is my score? Think about it. What is my score? My score is having this reference data. So when you are passing, what exactly you are passing? You are passing 0x400. So on this, initially, this will get 0x400. Now, what actually it means? It means that you have got two two variables, both are pointing to, right? Both are pointing to the same. It's pointing to this, it's pointing to this. Both are pointing to same. So that means now it doesn't matter, I mean, which variable you are going to use it, right? Ultimately, the moment, I mean, if you're going to change it, is going to be reflect to other places, right? To each other. So once again, I mean, this is what the difference is, that by value type and by reference type. Okay, so now let's move to another variation which we have. Let's see what variation we have got. Oh, very interesting. So we are talking about the string here. Okay, so in C sharp, string is having altogether a different, behavior. Um, so I just wanted to point it out here because sometimes, the interview, it is pretty classic question. People ask it, and then, even, the seasoned and programmers, I mean, get sometimes they are having difficulty to answer this one. So what is happening here? By definition, string is a reference type. Okay, so let's take a look what is happening here. So we have a stack, again the main stack frame. We have got variable s1 equal to hello initially, then we got variable s2 equal to s1. So what actually it means that, by we are having two variables, right? One and two. Okay, one is having hello and another one is having hello got, the initially hello got created here, and this is the hello address 0x400. So ideally s2 will have the 0x400, s1 will have the 0x400, so far by line 17. Okay, now let me clean this one. Oh, sorry, let me clean this one. So far, right, this is the scenario. Okay, now what happened? S1 equal to what, right? So we are changing into we are assigning into another value here. Now C sharp here does this thing very differently for a string. What actually it does, that it creates altogether a it allocates altogether a new space within the heap. Because remember, right, so far reference type, if you guys remember, right, whatever the example we have seen, what happens that when we change into the heap data, and so whatever the references and pointers are, right, it reflects in both places. Now very interesting thing is going to happen in this case, that we had 0x400 initially, both were having s2 and s1, but then the moment line 19 got executed, what it did, it didn't do anything with this. It ended up creating actually another space. Okay, another, it allocated the word actually into another, the another reason. It got a new location 0x400, and then it get back to s1. Okay, why it does that? The question is that why it does that, why it did that. Now what happened here, if you see here, so s2, see, the interesting thing is, so s2 is still having hello, but s1 is not now having word. Don't you think? I mean, it's a little bit, the contradictory, whatever the concepts we did so far. Ideally, since both are pointing to same reference and it is a heap, ideally, S1 and S2 both should have the word, but that is not how the string works, right? So C sharp does a little bit differently for the string. The reason being involved, neither I can all tell you that it is because of the, you know immutable. A string is considered as immutable. Now why in C sharp does like that, why we have implementation like this is a very interesting thing. I am going to leave this thing for you guys, that go ahead, research it, read it, and whatever you found, it, drop on my comments, or if you are not able to find, let me know. I can cover, as part of, some other episode. Okay, now moving to next, let's see what we have got. So example 6. Okay, now quickly I wanted to talk about the memory leak and the stack overflow. The reason being that obviously, since we are covering this, the topic, it is extremely important. Why even going in that detail, and we are trying to understand that which gets stored where, right? The reason being that still the responsibility lies on us, right? When we are coding, is we have to be extra careful that what kind of variables we are, they're declaring, we are assigning, and we have to ensure that, though I mean C sharp does most of, the memory management through the garbage collector, pretty nicely, but still there is a chance that if we are not careful, right, we will end up having, the situations like memory leak, the stack overflow. This is a pretty simple example. If you see here, we have a leak, the class where there is a, the list has been created, and what it does, that it creates this list here, but within this, the function, uh, it creates, the 1 megabyte, the space. Now what will happen if you are going to run it? I mean, this is going to be, I mean, you call it stack frame, is going to be created, and then, it keep allocating this one. Let me see if I have memory presentation. Yeah, so take a look what is going on here. So you got a stack, you got mainframe, right? And then, sorry, you got P, which is a, the reference type, and it is pointing to this address 0x600. And what it does, that it keep creating, the 1 megabyte space, 1 megabyte space, 1 megabyte space. And what is going to happen, it end up, it keep doing that. And if it's keep running like that, what will happen, that you will be out of the memory. Now quickly I wanted to touch base this one, the stack overflow. The same thing happen is if you are doing a recursive, if you are coding and you are putting, the recursive methods, you have to be extra careful, because this is one of the example. I mean, if you are not, let's say if we are not able to, by mistake or whatever, the situation is, if you're not able to find, the exit condition in your recursive codes, it will end up having, the stack overflow. The pretty simple example, if you see here, static void, let's start from here. Static void main, right? One local variable 99, then it is calling this function. What actually it means, that the moment this is going to be called, another, the stack frame is going to be allocated, which will have the local variable number. Okay, this is going to print it out, and then recursively you are calling it. Now in practical, what is going to happen, you will have main stack frame would be created. The moment the first time it is going to call this one, you will have the another try change int stack frame is going to be created. Once this is going to execute, again this will call this one, another stack frame is going to be executed. So it's keep calling it, keep calling it, keep calling it. And what actually will happen, that you will have infinite number of, the stack frame is going to be allocated. And obviously, I mean, before infinite itself, I mean, like I said, that stack hardly, it gets 1 megabyte space, so it's not having a lot of space, and therefore, I mean, it will be, the out of memory. A pretty simple, the memory presentation, how what exactly is going to happen. And if you see here, the 1 2 3 4 5 6, and then n number of times, and finally boom, you have Stack Overflow, the exception. uh, Now, before we close it out, I quickly wanted to cover the reference type as well. If you see here, um, you have the main method. You have one local variable 100. Then we are calling a function here. The magic is here. The difference, I mean, magic or difference, whatever we can say. Here we are passing, the ref score. Think about it, that if you are not putting the ref here, then score is a value type. So what actually it will do, that it's like, this will have their own copy. But the moment you do the ref, what actually it means, that you are not passing the actual copy, rather than you are passing the address, right? The memory like address. So once you do the memory address here, again, I mean, you are not getting the copy, but you are actually passing the actual memory addresses. Now if you change the value here, what actually it means, that you are actually, the changing the actual data. So this will end up having the changes at both places. Both the places, I mean that the original places. Okay. So I think we have covered, I mean, no, most of the scenarios, most of the possible, the permutation combination, which can be, which can be possible. Having said that, I mean, with this episode, I'm thinking that this was, the comprehensive breakdown of value types and reference types, and I'm hoping this has been insightful for you folks. Uh, it is a really nice concepts, which if you know, if you understand, I mean, it separates the, a basic C# programmer from someone who deeply understand, the runtime and engine, and how all this works, right? So if you find this explanation helpful, please give this video a thumbs up and subscribe to Step by Step Coding for more deep dives, and let me know in the comments what uh, any other C# concepts or any other programming language you would like, me to explore. Obviously my first target is that complete this, the series, and then I will try to cover anything else if you folks will like it. Thank you so much for watching.